Hey, good morning, everybody. This is Mr. Aynesworth again, and we're going to get into yet another lesson. And this time, we're going to be given a function, not the graph, and we're going to be able to determine the amplitude, the period, the shift, and the wave axis, and then use that information to graph the function. All right, so let's get on it here. So the facts are on the left, which I've already gone through. You should have already known these things right over through here. We're talking about the amplitude, the period, the shift, and the wave axis, commonly known as the midline here. Okay, some people call that the midline. And if you know your shift, well, then you know your midline because it's the y value. Okay, so here we go. Given this function here in example 4. All right, let's do it here. All right, so I'm going to solve for y here simply by adding 3. And I'm going to rewrite this. So add 3 here and add 3 over here. And you get y is equal to 2 times the sine of 5 times x minus 2, and then plus 3. And if you compare, here we know a few things we know. We know the amplitude is 2, okay? B is 5, and, excuse me, B is 5. So that's not B here. B is 5. So B, you need to know B in order to get the period, and the period is 2 pi divided by B. So in this case, since B is 5, it's very simple. I know that it's going to be 2 pi divided by 5, or 2/5 pi, right? And then we compare, okay? So I have to look at H and K to get my shift. So this is H comma K. And let me see, this has been shifted right 2 units and up 3 units here. So my shift is 2 comma 3 for the sine function here. And then the K value is 3. So my wave axis here is always y equals K. And in this case, it's y equals 3. Very simple. And then if you know all this information here, you can graph the function. So this is just a basic skill. Know how to identify these 4 things from the function. And after you identify them, of course, you got to graph the function. So let's get in on here. I'm not going to do all of these examples. I'll do a few, and then the rest is homework. All right, because it's one thing listening to me, but as I tell you in class, it's another thing doing it on your own. So you have to practice to get good, because listening to someone gives you the illusion that you understand it and then you can do it on your own. But the fact is that until you pick up the pencil, all right, and do it on your own, well, guess what? It's not as easy as you think, and you haven't mastered anything until you apply your learning to a wide range of examples. And only then can you say that you actually understand the material. So here we go. I've gone to first write the general function. So a times the sine of b times x minus h, and then plus k. There's your general function. That's translated as function here. So here I'm going to take this function and I'm going to rewrite it. Okay, I'm going to add 3 to both sides. So y is equal to 5 times the sine of 2x here. All right, add 3 to both sides, so plus 3. So I know a bunch of stuff. I know the amplitude is 5. I know b, and I know the shift. Okay, so there's no horizontal shift. There's only a vertical shift here. So let's write down our information here. So the amplitude, okay, is 5. Since b is 2, that tells me that the period is 2 pi. 2 pi divided by b. So this is 2 pi divided by 2, which is obviously pi. So the period is pi. And then I need to know a shift here. So there's nothing being subtracted from x. So h is 0, and then k is 3. So my shift here is 0, 3. So this is h and this is k. Okay, and then the wave axis, or your midline, is y is equal to 3 because the k value is 3. So once you identify this first, then you start graphing. And of course, you have to label the axis right here. Okay, so let me see. So this is, let me see, let's label 3, okay, because we have a wave axis at 3, so I'm going to draw this. Okay, so y is equal to 3, that's your wave axis. So the wave goes up and down through this wave axis here, or midline. And this is a sine sine function. So typically a sine function would start on the origin, as you guys know, but this has been shifted up 3, so we're going to start it here. So this is where sine starts. Okay, so instead of at the origin, we're going to shift it up 3, and then it has this up-down cycle. So what we want to do is go out, let me see, what's the period? Period is pi units. Okay, so go out 4, always go out 4 units or a multiple of 4. So 0, and then here, so you go out 4 units, label that pi, and then you break it up into 4 equal parts. Okay, now the amplitude's 5. So you have to go up 5. So we're going to have to extend the vertical axis here because I made the graph a little too small. Or I should have just brought down the x-axis. That would have been a lot easier. But anyways, 3, and then 4, and then 5. So this is 3 plus 5 is 8. Okay, so I'll label this 8 right here. And there's the amplitude. It says the amplitude is 5, so you got to go up 5 units above the wave axis. So A is equal to 5. And then 3 units below. 3 minus 5 is -2, so I got to go down here at -2. So what I do is I tell my students that, okay, draw the minimum, okay, which is 5 units below the wave axis, and then draw this dotted line above, and the wave's got to oscillate up and down through here. Okay, so again, 5 units below, so the wave, so you go 5 units below using the amplitude, 5 units above, and then again you start. Okay, now this has been you always break up the period into 4 equal parts. And a sine function, typically, we'll sketch a little function here, it goes up and then down and then back up again, okay? And so what we want to do is plot the 5 points like we normally do. 1, 2, 3, 4, 5. Okay, so here we go. So I'm going to go up to the max, down to the axis, down to the minimum. Okay, so this is the minimum. Up here was the max, and then back to the wave axis. And then you sketch. Put sound effects in. And that is 1 period only. Okay, again, the period here is pi units. P equals pi, period equals pi units. Always break up the period into 4 equal parts. We'll note here, very important note. Okay, always divide the period into 4 equal parts. Divide the period into 4 equal parts. That's why I went 4 units over, because you have to divide into 4 equal parts. And I don't care what the period is, that's what you do. Okay, so again, you plot 5 points. Let's highlight them. You start here at 0,3, and then you go up to the max, to the wave axis, down to the min, and then back to the axis. And that's typically what the parent function does. Remember, the parent function sine x starts at the origin, and it goes up, down, and then back up. So you have to know your basics here and apply the basics on your translated function with a new amplitude. And that's basically how it's done. And you just got to, again, get used to sine and cosine, because cosine's a little bit different, right? So speaking of that, I'll do one more here, and then you guys can do the rest for homework. Again, you're just applying what you know, okay? So let's try another one with cosine. Okay, so here we go. So this one is already explicit, meaning that y is already solved for. Here, let me just rewrite it just a different here. I'm going to switch the order here so you can see something. So I'm going to write it as 2 times the cosine of 1/2 x, right? This, when it's adding -2, that's the same thing as subtracting 2, and there you go. Okay, so now we can see the amplitude. I can see B, and I can see the shift. This is your shift. All right, so let's write down what we know. Okay, so I know the amplitude is 2. So I'm going to go up 2 and down 2 from the wave axis. If B is equal to 1/2, that tells me that P is 2 pi divided by B, which is 2 pi divided by 1/2. Multiplying by the reciprocal, you get 4 pi. Okay, so the period here now is 4 pi. And then what else do we need to know? We need to know the shift. So my shift, which is h comma k. There's nothing being subtracted from x here, so h is 0. And then, well, look here, it's a subtract 2, so it's a minus 2, so it's a down 2. So 0, negative 2, so down 2 here. All right, and then because the wave axis here, or the midline, is always y equals k, I know that y equals negative 2 for my midline, or for my wave axis. And so I'm going to go from y equals negative 2, I'm going to go up 2, down 2, and it's going to oscillate between there. So let's start graphing here. So I'm going to start, let me see, so at negative 2, I'm going to draw my wave axis first. So here we go. No. It's going to oscillate above and below this right here. So that's y equals negative 2, your midline or your wave axis. And then my amplitude is 2. Okay, so I'm going to go up 2. So there's my amplitude. And I'm going to go down 2 using the amplitude. And then the wave axis has to oscillate between these lines. So I'm going to draw this as a dotted line again. And it can't go above and below these dotted lines. It's got to oscillate in between there. Okay, so now we get started. So this is a cosine function, and cosine starts at a max. So let's see here. Amplitude of 2. So if this is the origin right here, I'm going to go up 2. So cosine would typically start here. All right, but it's been shifted, right? It's been shifted down 2, so you got to shift it down 2. So now we start here. Okay, because again, shift down 2. Shift down 2 units, because look at the shift, it's a minus 2. So it always starts on the amplitude on the y-axis. Now with an amplitude of 2, it typically starts at 0, 2, but this thing's been shifted down. So now I'm going to start at the origin, okay? And then here we go. Now cosine, you're going to remember the parent now. If I'm going to sketch the parent, it usually starts here and it goes down to the axis and then back up to another max. All right, so max to max. Okay, so we have to divide the period up into 4 equal parts. So here we go. I'm going to go from 0. I'm going to go 4 units to the right. I'm going to label this 4 pi. Okay, and I do that because I need to divide it up into 4 equal parts. So I start here, go to the axis, down to the minimum, back to the axis, and then to a max. So there's your max, and then I sketch the function. And this is one period only. If you want to do another period, well, then you just repeat the same process right here. And if you want to, you can graph as many periods as you want to. It's that easy. You just keep on repeating. So from here to here is one period only. It's 4 pi in this case. Here's another period drawn. So I just drew 4 periods, another one just for fun. Okay? And that's how it's done. It says graph for only one period only, but I just went another period just for funsies. Okay? All right. And there's another example. So I did one for sine and then the other one for cosine, but they're all done the same way, guys. Okay? And you just have to get practice to get good at it. And the only way you get good at it and develop a little speed is by practicing. So go ahead and make yourself proud and do your homework, and then check my instructor's notes for solutions, or you can check with Desmos, either one, right? I taught you how to do that in my last video. So there you go. There's how you graph sine and cosine functions. And then last and final lesson here, we'll kick in some reflections because I haven't done that yet, but we'll see that in the next one. It's Aynesworth. See ya. Bye-bye.